Welcome back to the Retro Remix project in Unity. In this video we will take a look at the Lemurs game and answer the question, how can we put an infinite number of levels into one level scene? If you remember from the introduction, all the levels in the Lemurs game are defined in scriptable objects. You can find them here in the scriptable objects folder. And here we define how many abilities we can assign, how many lemurs should get spawned, and what image we want to use for that level. And that is all a level needs. A level does not have a certain level scene like in Roller Maze, and all the scenes we have in Lemurs is the main menu and a level scene. And the level scene just takes that data and displays the level accordingly. The class responsible for this setup is the level manager, and you can find it here in the level scene on this game object, level manager. Here you have the level manager script. Let's take a look at that. The level manager is a singleton, but it will not stay between scene changes. So every time we load the level scene, the level manager gets constructed from scratch, and by that the awake and start methods do get called. Let us start with the awake method. Here you can see that we load the level data from the game manager. We get the current level data. So the game manager knows in what level we are right now and delivers us the scriptable object for that level. You can see it here. Level data is of the type level data, and there is all the data stored that you have seen right now in the scriptable object. And with that level data, we first create a dictionary where we store all the available abilities so we can find them later on more easily. And the very important part is we set up a map variable that is of the type map. And here in the constructor, we give that map class the level data we have read from the game manager and the lemurs list that is initialized here that stores all the available lemurs that get spawned in that level. Let's take a look at that class. Here in the constructor, we set up a few variables we need. For example, we define what our clear color is. If you remember from the introduction, lemurs can only walk where the background is, and the background is defined by the black color. You can see it here in the example. Only where black pixels are, a lemur can walk. And all these variables here are used when we actually manipulate the levels by assigning tasks to lemurs. For example, when we dig down in the ground. But let's focus on our setup here. We create in this constructor also a new object map data, and we give that map data constructor the level texture that is defined in the scriptable object. That means the map data now knows about the texture that we want to use for that level. And let's take a look in that. And the map data is responsible to store the texture of the level and an array of colors of that texture. You can see it here. We have a texture 2D in that class and a color array. And here in this only method in that class, we generate that texture and the data for the color array in here. Here we get the original texture from the scriptable object, and we have to copy that because we don't want to operate on our original texture, because then it would be unusable for the next playthrough. For example, if we have dug a few holes in it or built a few stairs, then the next time the level would launch, all the holes and stairs would still be in there. So we are just making a copy here. And we're doing this by creating a new texture 2D, setting the filter mode to point to have it crisp as the original, and also set up the color array. And then we loop through the whole texture and read the pixels from the original texture and store the color information in the color array. And then we also set the pixel in our newly created texture. So in the end, the new texture has the same color information as the original texture. And the reason why we're using this color array here, and not only the texture, First, it is more efficient to read from an array and not to read directly from the texture. And for the collision detection, we read a lot of that data. For example, when a lemur walks around in the level, then we need to check if the next pixel the lemur wants to walk to is black or not. And that is much faster if we are using that array. And also in that color array, we store a few values that are not visible in the actual texture. We will come to that in a minute. So after creating the new texture, the map data here is stored in the map class, and here we also create the minimap texture for our small minimap at the bottom of the screen. The map class also has many helper methods. For example, here in the region functions for changing the map, you can find a few methods that will actually change a level map. For example, here when we assign the task of digging down to a lemur, then we need that method clear horizontal line at position. And what that does, it sets the pixels on the level texture, and it also sets the colors in the color array. So setting these in the texture is the visual representation, and this here is the data representation that we use to check for collisions. And here you can see we are using set pixels, not pixel, because we want to set 9 pixels in a horizontal line. And it is much more efficient to set all the pixels at once. That's why we have defined a clear line. That is this array here. And it consists of 9 entries of black color. And that way we can easily set all pixels at once and apply them. So these are a few methods that manipulate the level, and they always adjust the texture of the level and the color data array. With one exception, we have built invisible wall at position here, for example, and here we have commented out that the visual representation of the level, the texture data, is manipulated. So we don't see the walls in the texture. They are only set in our color array, and they are important for collision detection. A lemur can pass that walls, but we don't want to see them. And they are used, for example, for the stopper lemur. When a stopper lemur is set, then left and right of them, an invisible wall is placed so the lemurs can pass, but we don't want to see the wall. So you can find all these manipulation functions here in that region. And then we have another region to check for collisions. For example, to know if a lemur can walk to a certain spot, we have a method isFreeSpot, and then we check here in the map data color array if this is a black color, and if it is, then the lemur can pass, and we return true, yes, this is a free spot. We will revisit these methods when we come to the lemur class and see how they move around in the level and use those methods to detect collisions. So let's go back to the level manager. After having created this new map with all the data and the new texture and so on, awake is finished and then start gets called next. And in our scene we have a sprite renderer to display the level. You can find it here. That is the level renderer. It has a sprite renderer and that displays this image here. And this needs to get changed to the actual texture we want in the current level we are in. So we need to change the sprite here in the sprite renderer. And that is done here in the start method. With our copied texture that we find in the map data level texture, we have to create a new sprite from that. And we can do it by using sprite.create and insert the created texture here. And also set the pixels per unit to 1. You can find these settings, for example, here on the sprite import settings. Here we have set the pixels per unit to 1, so that each pixel represents 1 unit in Unity. And this was all the hard work so far, and now we just have to set the exit gate and the spawn gate to the locations we have defined in the level data. You can find them here in the scriptable objects, spawn position and exit position, and these are exit gate and spawn gate. this item here. Then we also inform the level UI manager about our available abilities we have for that level, and that sets the Text Mesh Pro objects here for these white boxes. The level UI manager you can find on the main canvas. Here it is. And that has references to all these text fields that are on those white boxes. And there we set the available amounts of that certain ability. And that's how the whole level is set up. To summarize, we read the data from the game manager, from the scriptable object for the current level. Then we create a new map object that contains the map data, the color array where we check for collisions, and the texture we made a copy of. After that, we create a sprite from the texture and assign it to the level sprite renderer, set our exit gate and spawn gate, set up the UI accordingly, and then we show the level start screen. So at this point in the game, everything is set up and we're waiting for a mouse click from the player, and then start level here gets called and this set has started to true. And from that point on, the update loop here in the level manager can run, check for input, assign tasks to Lemurs, and advance the timers, update the status text, and so on. And that is something we take a look at in the next video. I hope to see you there. Until then, happy creating and take care.